All right, grab your detective hats because today we are on the case of a nearly 2,000-year-old mystery. We're talking about a hidden genius, lost books, and a tiny note scribbled in a margin that stumped the world's greatest minds for centuries. So let's open the case file on Diophantus.
So, first question, who was this guy? And well, that's puzzle number one. You see, for most famous people from history, we've got letters, records, biographies, something. But for Diophantus of Alexandria, we have almost nothing. In fact, the single biggest clue we have about his entire life is a math problem.
No, I'm not kidding. Pretty much everything we know about this giant of mathematics comes from just one place, a riddle that was supposedly written on his tombstone. It was saved for centuries in a collection of poems called the Greek Anthology, and honestly, it's less of a biography and way more of a brain teaser.
And this is it. This is our main clue. It's basically a story problem. It says his boyhood was 1/6 of his life, then his youth was another 1/12, he waited another 1/7 of his life to get married, and then 5 years later, a son was born. The riddle goes on to say his son lived for half his father's total life, and that Diophantus himself died just 4 years after that. His entire life story is laid out, but it's all in fractions and little pieces. It's like he's challenging us from beyond the grave. If you can do the math, you can figure out how old I was.
Okay, so how do we crack this thing? Well, we use the very tool that Diophantus was a master of, algebra. Let's just call his total age x. Now we can translate the riddle bit by bit. His boyhood was 1/6 of his life. That's x over 6. His youth, another 1/12, so x over 12. He waited another 1/7 of his life to get married, x over 7. Then you have the hard numbers. 5 years pass before his son is born. His son lives for half of his dad's life. That's x over 2. And then finally, Diophantus grieved for 4 more years. You add all of that up, all the fractions of his life, plus those fixed years, and it all has to equal his total lifespan, x.
So you do all the math, you solve for x, and you get 84. The man whose life was literally a puzzle lived to be 84 years old, an incredible life all wrapped up in one perfect algebraic riddle. But you know, the mystery of his age? That's just the beginning. The real story is what he did during those 84 years.
Solving for x feels pretty normal for us now, right? But back in the 3rd century AD, this was absolutely revolutionary stuff. And that brings us to Diophantus's masterpiece, a book that would literally change math forever, the Arithmetica.
Now, the Arithmetica wasn't a textbook like we think of them. It was more like a workout book for your brain. It was a collection of almost 300 problems, and every single one was a puzzle just waiting to be solved. They went from pretty simple equations to these incredibly tough problems in a field that we now call number theory.
And this right here shows you his biggest game-changing idea. Before Diophantus, doing algebra meant you had to read through this nightmare of words. Just look at that top example. It's a total mess, right? It's so hard to even figure out what it's asking. Diophantus saw that and just knew there had to be a better way. The notation you see at the bottom, that was his solution. I know, it looks pretty alien to us, but for his time, it was a gigantic leap forward.
What he came up with was a kind of mathematical shorthand. We call it syncopated algebra. He was one of the first people ever to use a symbol for an unknown number. Think of it as the great-great-grandfather of our modern x. He even had symbols for things like squared and cubed, and for subtraction. It wasn't quite the algebra we use today, but it was a massive, massive step away from writing everything out in long, painful sentences.
Now, you'd think a book this important would be locked away in a vault somewhere, right? Well, the story of the Arithmetica is just as wild and mysterious as its author's life. It's an incredible tale of being lost, translated, and rediscovered over more than 1,000 years.
I mean, just look at this journey. Diophantus writes his 13 books around 250 CE, but then during the Dark Ages, they pretty much vanished from Europe. But lucky for us, scholars in the Islamic world knew how important they were. In the 9th century, the book was translated into Arabic, which saved it from being lost to history forever. It didn't pop back up in Europe until the 16th century, and then in 1621, a new Latin translation came out. And get this, as recently as 1968, 4 of the original 13 books, which everyone thought were gone for good, were discovered in Iran. They had been preserved all that time in that Arabic translation. Just incredible. The story gets even crazier with that 1621 edition. Why? Because a copy of that book ended up with this brilliant, kind of mischievous French lawyer and amateur mathematician named Pierre de Fermat. And Fermat, well, he liked to write in the margins of his books.
So Fermat was just completely hooked on Diophantus's work. He'd read through the problems, solve them, and make his own little notes. And while he was looking at a problem about splitting a perfect square into two other squares, a squared plus b squared equals c squared, like Pythagoras' theorem, Fermat started wondering, could you do the same thing with cubes, or any power higher than 2? And then, right next to that problem, he wrote this legendary, tantalizing, and, let's be honest, totally infuriating note. He basically said, I've discovered a truly marvelous proof for this idea, but this margin is too small to write it down. And then he just moved on. He never wrote that proof down anywhere else, ever.
That one little note kicked off the single most famous unsolved problem in the entire history of mathematics, what we call Fermat's last theorem. It took the best mathematicians in the world 358 years to finally prove that he was right. The proof, which was finally finished by Andrew Wiles in 1994, used math so advanced it didn't even exist for centuries after Fermat. And it all started with a scribble in the margin of a book written by our ancient algebra detective Diophantus.
So, after all the riddles and the lost books and the legendary margin notes, what's the lasting impact of this super mysterious figure? What did Diophantus really give to the world?
Well, his legacy is absolutely huge, even if his name isn't a household one. Today, anytime you're looking for whole number answers to an equation, you're actually solving what's called a Diophantine equation. He helped build the entire foundation for number theory, which is the deep study of integers. His brilliant idea to use symbols paved the way for the algebra we all use in school. And as the story of Fermat proves, his work has been inspiring and challenging the greatest mathematical minds for almost 2,000 years. Now, you'll often hear Diophantus called the Father of Algebra, but history's a little more complicated than that. About 600 years later, a Persian scholar named Al-Khwarizmi also earned that title. So, who is it? The truth is, they both are, really. Think of it this way. Diophantus was the pioneer who used symbols to solve very specific, brilliant problems. Al-Khwarizmi came along later and gave us a systematic, step-by-step method for solving equations. He even gave us the word algebra itself. They're like two different but equally vital pillars holding up the entire structure of modern math. The story of Diophantus is just this powerful reminder that sometimes the biggest discoveries aren't in the main text of a book. They're in the questions that book makes you ask, and in the little notes we leave behind for others to find. It really makes you wonder, doesn't it? What other incredible secrets are still out there, just hiding in the margins of history? Thanks for joining the investigation.